So we will pick up in the obviosities chart, or on the obviosities packet, I should say. It is on number 3, which is the bottom half of the first page. Okay? So some quadrant observations that we can see from the obviosities. First off, refreshing our memory that that is quadrant number 1. That is quadrant number 2. There is 3. And there is 4. Okay? Cosine. Cosine of t is positive in which quadrant? 1 and 4. Do we agree with 1 and 4? Cosine is x or y? Cosine is x. Okay, so cosine would be positive then in quadrants 1 and 4. Correct. If cosine is positive in 1 and 4, where is cosine negative then? 2 and 3. Okay. So really, we're talking about that cosine is positive on the right side and cosine is negative on the left side. Would you agree with that? Because that's x is positive to the right of the y-axis and x is negative to the left of the y-axis. Okay. What about sine? 1 and 2, so the top half. Negative 3 and 4. Which is the bottom half. What about tangent? Where is tangent positive? 1 and 3. Okay? Tangent's positive in quadrants 1 and 3. I don't have a side for those. Which means tangent is negative in 2 and 4. Okay? All told, we can say it like this. What does that mean? Okay. But what does it mean? And that's where everything's positive, right? So in quadrant 1, all of them are positive. In quadrant 2, just sine is positive. The other 2 are negative. Quadrant 3, tangent's positive. The other 2 are negative. Quadrant 4, cosine is positive. What about secant, cosecant, and cotangent? The other 3 of the 6.
opposite quadrants.
No. Be the same. So secant would be the same quadrants as cosine, because secant and cosine are pairs. Okay? So likewise, cosecant and sine would be the same. So cosecant would be positive in quadrants 1 and 2, negative in 3 and 4. And cotangent would match up with tangent. Okay? Good times. Good times. Okay? Sine, cosine, tangent. Secant, cosecant, cotangent are all what are called periodic functions. Meaning that there's a specific period or a specific distance, if you will, and they will repeat themselves. Okay? What I mean by that is, if I set a t value, and then I wrap that t value onto the unit circle. Maybe not quite that far. We'll say in there. Okay. When will I get the exact same values for sine, cosine, tangent, cosecant, secant, cotangent? What's the distance that I have to go again to get those all 6 to be exactly the same? Not just 1, not just 2, but all 6. What would I have to do to my t value?
You can probably increase it by 2 pi.
Why 2 pi?
Because that's one more revolution around the circle.
One more lap around the circle, right? So if I go over here to Sarah Colehap's wonderful unit circle, okay, and let's say that I'm at pi over 3. Okay? At pi over 3, my cosine value is 1/2. My sine value is the square root of 3 over 2. My tangent value is the square root of 3. My secant value is 2. My cosecant value is 2 divided by the square root of 3. And my cotangent value is 1 divided by the square root of 3. Okay? Those 6 will not all be exactly the same until I come all the way around the circle and start over again. What if I went around twice? So if I went 4 pi, would they be the same again? Yeah. What if I went around 222 pi? Would they be the same again? Yeah, because I went around a multiple of 2 pi. What if, instead of adding 2 pi to pi over 3, can I subtract 2 pi? Does that make sense? Can I subtract 2 pi? So instead of going this way around the circle, if I subtract 2 pi, which way am I going? going clockwise around the circle. As long as I go a full, complete lap I'm okay. So in here, if I have the cosine of t, or the sine of t, or really any of the 6 functions there, that's going to be the same as the cosine of t plus or minus 2 pi. Because 2 pi is a full, complete lap. Sometimes I might have to go 2 laps. Maybe I gotta go 3 plus or minus 6 pi. Maybe I gotta go 41 laps plus or minus 84 pi. Excuse me, 82 pi. So on and so forth. Get out your unit circles if you haven't gotten them out already, because we're going to use them, or if you can see all the way up here to the front board. Okay? 13 pi over 6. Is the t value, my angle of 13 pi over 6, is that on my unit circle as written? Nope. Biggest one I got is 12 pi over 6, right? Okay, which is 2 pi. Okay. So in my brain here, I am going to do some side math, some thinking about things. So since I have a positive angle that is not on my unit circle, I'm going to take away a lap. Okay, so I'm going to subtract off 2 pi. But my 2 pi is not going to look like 2 pi. My 2 pi in this case is going to look like 12 pi over 6. "13 pi over 6 minus 12 pi over 6 gets me pi over 6. So the sine of 13 pi over 6 is the same as the sine of pi over 6. And now that is on my unit circle. And so I can look and I can say sine is the y part of the point at an angle of pi over 6. And in this case, the sine at pi over 6 is 1/2. Agree? I'm going to skip down to number 3. Number 3 says I've got the sine at negative 7 pi over 4. Now, because that angle is negative, I'm going to add, 2 pi to that. Negative angles I add, positive angles I subtract to get them back onto the unit circle. In this case, my 2 pi, because I've always got to add 2 pi, but in this case, my 2 pi is going to look like 8 pi over 4. So the sine at negative 7 pi over 4 is the same as the sine at pi over 4. which is the square root of 2 over 2. What I'd like you to do now is I would like you to do the remaining 5 questions there at the bottom of page 2 of your Obviosities packet. So 3 pi, if I subtract off 2 pi, that puts me at pi. So this would be the cosine at pi, which the cosine at pi is the x value at pi, which is -1. Agree with that one? Okay. Love it. Shout out questions if you got them. Cosine, -13 pi over 3. So that's -13 pi over 3. I'm going to add to that 6 pi over 3, because that's my 2 pi, right? But that only gets me to -7 pi over 3. Still not on there. So I got to add 6 pi over 3 again. That gets me to -pi over 3, which I could get to, because I could go -1 pi over 3. Okay? Or I could add 6 more pi over 3, and that puts me at 5 pi over 3. So this is the cosine of 5 pi over 3. X value at 5 pi over 3, I get 1/2. Agree? (17 pi over 3). If I go around once, I'd be subtracting off 6 pi over 3 again, right? So that would get me down to 11 pi over 3. If I go around a second time, that puts me down to 5 pi over 3. So I'm going to really subtract here 12 pi over 3, which also puts me at 5 pi over 3. So this is the sine of 5 pi over 3, which is -√3 over 2. Agreed? -19 pi over 6. If I add 12 pi over 6, that puts me at -7 pi over 6. If I add 24 pi over 6, that puts me at 5 pi over 6. So that would be the tangent then at, bless you, 5 pi over 6. 5 pi over 6 tangent is y divided by x. So that's going to be 1/2 divided by -√3 over 2. So that simplifies to be -1 over the square root of 3, or -√3 over 3. Either one of those works for me. 100 pi. If I subtract off 2 pi, I'm at 98 pi. Subtract off 2 pi, I'm at 96, 94, 90, spinning. Getting dizzy from all the spinning. Okay? Right? So if I go around 50 times, that's 100 pi, which means I'm at 0. So this would be the sign of 0, which is 0. Yep. Unit circle memorization quiz is next week, Monday or Tuesday, whichever day you have before my class period, along with some more abvyasas. You can convert them if you do, but no, you do not.
Okay.
For the quiz, no. For life, yes.
Yeah.